Hello, you nines. My name is Mr. Lead, and today I'm going to be taking you through three quick questions. Hopefully, taking you through these three quick questions will give you a better understanding of electricity. So, the three questions I have are, how do you measure current, how do you measure voltage, and how do you change the current in a circuit? So let's take them one by one. First one, how do you measure current? You might think, don't you just use that device you use to measure current? An ammeter? Don't you just use an ammeter? Well, yes, but you got to understand how you use an ammeter. How does an ammeter work? So to understand that, firstly, you got to remember what current is. Current is the rate of flow of electric charge past a point or region. So I'm going to create a point or region for my ammeter here. This is FET, by the way. This is the simulation. I'm going to create a point or region for my ammeter here. That's an ammeter to measure the flow of electric charge. So an ammeter, for an ammeter, you need to put it into a circuit to measure the current. So I put this ammeter into the circuit, and it's now measuring the the rate of flow of electric charge past this point. And we've discovered that the rate at this point is 3 amps. And to note is with ammeters is that they have an incredibly low resistance. Every time you put something into the circuit, it's increasing the resistance, which affects the current. But an ammeter has such a low resistance that you can put it into a circuit without really affecting the current itself. It can measure the current without really affecting the current itself. So that's answering the first question. How do we measure current? We use an ammeter to measure the current at a point or region. One, how do we measure voltage? Now, measuring voltage is a bit trickier to understand than measuring current. And I'll show you why. Let's get our voltmeter out. Now, the ammeter was simple. We just plugged it into the circuit and it measured the current. We can't plug this voltmeter into the circuit anywhere. In fact, our voltmeter has these two points that we need to measure with. So let's use these 2 points. And what? The voltage is 0? The voltage is clearly not 0 in this overall circuit. What's it? How do we use this voltmeter? So to understand that, you need to better understand how voltage works. So remember, voltage is the difference between electric force between 2 points. So measuring voltage is kind of like measuring a gradient in maths. When you measure a gradient in maths, you need to get 2 points and you measure the difference between them. That's the same for voltage. Now, before I was explaining voltage, at one point I was explaining voltage, hang on. Okay, here we go. Before I was explaining voltage in terms of water. I was showing water as an example of how you can think of electricity. Voltage is like water pressure. It's what's pushing the charge onward. Here's another way to think about voltage when you think about it in terms of a circuit. When you plug a battery into a circuit, that's giving a higher electric potential to all the electrons. But when you plug in a load to a circuit, that's taking away all that electric potential. It's using up all that voltage. So here we've got a circuit. This is like, I'm going to press play. This is like the battery. It's getting all the electrons to a higher state of electric potential. And on the other side, this is like a light globe or a resistor or something. It's bringing the electrons down to a lower state of electric potential. Okay? So imagine if we're getting our voltmeter. We'll go back to FET here. Imagine that in the scenario of this circuit. So the electrons are flowing this way. The electrons on this side are kind of like on that higher level, and the electrons on this side are on that lower level because we got the resistor here. I'll take out the ammeter. We got the resistor here. So remember, this is like the resistor. This is the battery. The battery is bringing the electrons up. The resistor is bringing the electrons down. Back on FET, the battery here is bringing these electrons up and the resistor is bringing them down. So when we use our voltmeter, and if we pick 2 random points, not any 2 random points is going to show a measure of voltage. There is no difference in electric potential on these 2 points I've picked. But on the other side of the resistor, now we see a difference. We see that this resistor is causing a drop of 6 volts. So we see that overall in this circuit, we're seeing an overall potential of 6 volts. It's really important you understand this concept of how voltage is being used up somewhere within the circuit. The voltage is being dropped, the electric potential is being dropped somewhere within the circuit. I'm going to click values here. This resistor has 2 ohms of resistance. Now, what if we come to a circuit which has 2 resistors? I've now got 2 resistors, each with 1 ohm of resistance. So the overall circuit has the same amount of resistance. But what would happen if we tested the voltage between these two points? We get 3 volts instead of 6. We got 6 last time, but now we've got a resistor, 2 resistors. We get 3 volts instead. And if we test between here and here, we get 3 volts again. But if we test overall, it's 6 volts. So we got the same amount of resistance. Overall, that's still a drop of the same amount. That's 6 volts because this battery is only producing 6 volts. But whenever you add another resistor in, that's evenly split. As long as the resistor still has the same level of resistance, you're evenly splitting up, you're evenly dividing that voltage, and the voltage is being dropped evenly at each point. Kind of compare that idea of adding more resistors or adding more loads to a circuit. This diagram here doesn't show it, but imagine we have, instead of 1 little water wheel, we got 2. So that means the electric potential will drop like halfway after the first one and half after the second one. The electric potential is divided across different loads, and then it's always brought right back up at the power source. So we can kind of imagine this better with light globes. This light globe has got all that 6 volts of electric potential all to itself, but these light globes have, because there's 2 of them now, they each only get 3 volts. They have to share that 6 volts across and between themselves as 3 volts and 3 volts. 3 volts, there you go. I said before, you see the dividing of voltage to be even only if the resistance between all the loads is even. So I've got here in this circuit 3 resistors, and one of them has a different amount of resistance to the others. So you see this resistor is using up 3 volts, but because these other ones have different amounts of resistance, they're only using up 1.5. Okay? All right. One quick last thing to note about how you use voltmeters is voltmeters and a lot of electrical appliances in general have a positive and a negative terminal. The black one here is the negative terminal. The red one here is the positive terminal. Now remember, electrons flow from negative to positive, okay? So we need to put in the black one first and then the red one second. If we reverse them, and if we do it the other way round, we get a negative reading because we are measuring the electric potential in the wrong direction. So it's actually kind of handy to know that black is negative and red is positive, because if you ever come to a situation where you need to jumpstart your car, you need to know these things about electricity. So how do we measure voltage? Voltage is the difference between electric force between 2 points. So you use a voltmeter to measure voltage, but it doesn't work the same way as an ammeter. We can't just plug it into the circuit. We need to create it. We need to have it separate to the circuit and measure it at 2 different points. If we see here, here's an ammeter and a voltmeter in real life. So here we have a massive power source. You can think of this as like a battery, but it's not. It's a power source. We've got the electrons flowing through a circuit like this, and it's flowing through the ammeter. The ammeter needs to be put into the circuit, but this voltmeter is branching off to the side, and it's measuring the electric potential before the electrons go through the light bulb and after the electrons come out of the light bulb. It's measuring the potential on either side of the light bulb. So voltmeters need to branch out from the circuit, and ammeter you put into the circuit. Okay, last thing I'll mention, or I'll talk about here, is how do you change the current in a circuit? Now this might seem a bit of an odd question, but here's the thinking behind this that some people might have. You can change the voltage and the resistance easily. You can manipulate a circuit to directly change the voltage and the resistance. So say I want to add more voltage, I just add another battery. There we go, my circuit has more voltage. So I can now see, I now see I've got 15 volts I've got 15 volts instead of 6 volts. To change the resistance, I need to add more resistance. I need to add a stronger insulator or a stronger conductor. That's the ways you change the resistance. So voltage and resistance, you can directly manipulate those two factors. The current, on the other hand, you can't really add something that just changes the current, or you can't do that directly. Instead, to change the current, you need to change the voltage or the resistance, because current is relative to voltage and resistance. That's what Ohm's law is about. Ohm's law is showing that current is voltage divided by resistance. So you can change if you change the voltage, you see the current is changing. So yeah, that's how you change the current. Voltage and resistance are like independent variables. You can directly manipulate those, but the current you only see as a dependent variable. It's changed in response to a change in the voltage or a change in the resistance. Okay, so that's the answer. Those are the answers to these three questions. I hope that this might have given you a bit of a broader understanding or a better understanding of electricity. Okay,